Knockout takes, Almunia saves, knockout follows in, Almunia saves again! Absolutely astonishing. Now here come Watford. Forestieri. Here's Hogg! Do not scratch your eyes. You are really seeing the most extraordinary finish here.
What is a limit? It is the best prediction of a point we didn't observe. Example, we have here the limit of a function as x approaches to 6. As the value of x gets closer to 6, the value of y gets closer to 4. That's why the limit of the function as x approaches to 6 would be 4. By definition, a limit of a function where f is a function defined at every number in some open interval containing a, except possibly at the number a itself, the limit of a function as x approaches to a is L, written as this. There are three methods in finding the limit of a function: graphical, numerical, and analytical. Let's start with numerical. Suppose you have a function f of x is equal to x over 2 as x approaches to 2. We need to construct a table of values of x from left and right of 2. So we have here, from the left of 2, 1, 1.5, 1.99. And then from the right of 2, we have 3, 2.5, and 2.01. So if we complete this table, we have 0.5, 0.75, and 0.995. And then from the right, we have 1.5, 1.25, and 1.005. So if we notice, the value is getting closer to 1. If we check the graph, as x approaches to 2, the values of y approaches to 1. Another example, suppose you have a function f of x equals 1 over x as x approaches to 0. Here we have the table of values of x from left and right of 0. So from the left, we have negative 1, negative 0.5, negative 0.01. And from the right, we have 1, 0.5, 0.01. If we evaluate the values of our function from the left, we have negative 1, negative 20, and negative 100. And from the right, we have 1, 20, and 100. Since the value from the left and right of 0 does not approaches to the same particular number, then the limit of the function as x approaches to 0 does not exist. If we look at the graph as x approaches to 0, we could see that the graph are turning to different directions, so they will not meet on a particular point. That is why the limit of the function does not exist. Now, let's try to find the limit of a function using the graphical method. Here we have the graph of a piecewise function. First, we have the limit of the function as x approaches to negative 5. So the answer is negative 2. Second, we have the limit of the function as x approaches to negative 2. Since the graph does not meet on a particular point, then we could say that the limit does not exist. Third, we have the limit of a function as x approaches to 0. And the answer is 0. Fourth, we have the limit of the function as x approaches to 1. Then we could say that the limit is equal to 1. And then number 5, we have the limit as x approaches to 2. Then we could say that the limit does not exist. And lastly, the limit of the function as x approaches to 4 is 6.